Hello everyone. Our discussion is still on acids and bases, but this time it's about predicting equilibrium direction. Let us start with recalling our definitions. The product that results when an acid loses a proton is called the conjugate base of the acid. And the product that results when the base accepts a proton is called the conjugate acid of the base. Let us consider the given reaction. The reactants both contain hydrogen. But if we examine the products of the reaction, what is formed is H2B, meaning HB in the reactant accepted a proton from HA. Therefore, HA acted as the acid, HB acted as a base. The conjugate acid is H2B. This is the conjugate acid of this base. And what is left behind when an acid removes a proton or donates a proton is called the conjugate base of this acid. Maingay ang mga asko. Pasensya na. Okay, let us recall our activity last time. Last time, you were given this table as your guide in the exercise. In the exercise, you were given acids to arrange according to their increasing strengths. Likewise, their conjugate bases. What do you observe in this table? As you go down, the acid becomes stronger. That is the opposite on the other side, where the base becomes weaker. Okay, inverse relationship. Take note also of the pKa values, that if the pKa is a big number, it means it is a weaker acid. If a pKa is a small number, naging negative na nga, it becomes a stronger acid. To understand the inverse relationship, let us consider what is happening to the acid, particularly hydrogen, in the acid-base reaction. Okay, let us recall that a strong acid is the one that loses hydrogen easily, meaning that its conjugate base holds the hydrogen or the proton weakly, and therefore a weak base. A weak acid is one that loses the proton with difficulty, meaning that its conjugate base does hold the proton tightly and is therefore a strong base. In the given reaction below, what we have here is acetic acid and water. Okay, which one accepts the proton? Water accepts a proton from acetic acid to form the hydronium ion. And what is left behind of the acetic acid is the acetate ion. The fact that that acetic acid is a stronger acid than water means that the acetate does not hold the hydrogen tightly and is thus a weak base. Okay, so the acetic acid here is a stronger acid, therefore its acetate ion, the conjugate base, is a weaker base. Stronger acid, weaker base. Water, on the other hand, is a weak acid, meaning that its OH holds the hydrogen tightly and is a stronger base. Let us recall our definition of Ka and pKa. These two expressions here are equivalent. In the first one, water is involved. In the second one, you don't see an expression for water, but these two expressions are equivalent. Okay, the pKa expression, which is negative log of Ka, are the same. Another way to predict acid-base reactivity is to remember that the product conjugate acid in an acid-base reaction must be a weaker and less reactive than the starting acid, and that the product conjugate base must be a weaker and a less reactive than the starting base. So if you are given this example, okay, first reaction is between a carboxylic acid and an OH. This is the carboxyl group and an OH group. pKa of the carboxylic acid is 4.75 and the pKa of the conjugate acid water is 15.7. Which is the stronger acid? Okay, remember from the table that if the pKa is a small number, it is a stronger acid. And so the direction will be going to the right. Going to the right. Now, let us consider the second example. HCN, and again, this is a carboxylate ion. Hydrocyanic acid and a carboxylate ion. Okay. pKa of HCN is 9. pKa of the carboxylic acid is 5. So, which is the stronger acid? HCN or carboxylic acid? Since this is the lower number, what do we know from the table? If the pKa is a lower number, it is a stronger acid. So the direction is from stronger acid to weaker acid. Now, it is for the third example, it is going to be your work, something to think about. Which is the direction of the equilibrium? Is it going to the right or is it going to the left?